Alright, 23. Let's continue along here. Write the equation of the line containing the points 7, negative 13, and 12, comma, negative 23. Alright, first I'll show you the algebraic method, then we can check our work on the calculator. We'll write our tiny table right here, and we'll put our two data points, 7, comma, negative 13, and 12, comma, negative 23. We measure our change in y between these 2 points. So to get from here to here, we subtract 10, and then we measure our change in x. To get from here to here, we add 5. So our slope is equal to change in y over change in x, which equals negative 10 over 5, which is equal to negative 2. So there's our slope. So we'll use our point-slope form of the linear equation. Y equals m times the quantity x minus h plus k. We'll sub in our m, which is negative 2, x. So we'll choose an h comma k. So let's choose 7 as our h and 13 as our k. So x minus 7, k, so y is negative 13. Because remember, we choose an ordered pair at a point h comma k, where h is 7, k is negative 13. And let's go ahead and distribute. So that's negative 2x plus 14 minus 13. And that equation becomes negative 2x plus 1. Alright, so let's see if we calculated it properly. Let's fire up our calculator here, turn it on. And I already have the ordered pairs in here, so 7, negative 13, and 12, negative 23. We go to Stat, Calc, Linear Regression, hit Enter, and sure enough we get negative 2x plus 1. What is the rate of change of the function x equals negative 5 and y equals 4? Okay, well, for x equals negative 5, that function looks like this. 1, 2, 3, 4, 5. X equals negative 5 is this line right here. It's a vertical line where every single x value on the line equals negative 5, right? All these x values are negative 5. Well, this has an undefined slope. So slope is undefined here. But at y equals 4, 1, 2, 3, 4, it's a horizontal line where every single y value on the line equals 4. And this slope, it's flat straight across, so this slope is 0. So those are the two slopes of those lines. Alright, let's talk about 25, which looks like it's an inequality problem. Eric's history grade will be determined by the average of 4 tests. He receives a 76, an 85, and a 74 on the first 3 tests. So he got a 76, he got an 85, and a 74. He needs to get an average of at least 80%, to receive a B. Write an inequality that can be used to find G, the minimum grade he must make on the 4th test to receive a B in history. So we know how to average numbers. We add up all the numbers and then divide by the total amount of numbers. So these are the first 3 grades he got. Grade 1, grade 2, grade 3, and grade 4, which is what we're trying to solve for. And we divide all that by 4 to find the average. And we're just trying to write the inequality. We don't have to solve for G. So it needs to be at least an 80. So this needs to be at least, so greater than or equal to an 80. So the key here is to be able to figure out that this at least 80 at least needs to be represented by this expression right here. Alright, so that expression will be fine. To solve this, we'd multiply each side by 4 and then subtract these numbers like that. But this is the answer right here for 25. Okay, let's take a look at 26. A small business purchased a van to handle delivery orders. The graph below shows the value of the van over a period of time. So, value of the van is decreasing as years go by. So, what describes the situation? Van was purchased for $1,600. Van decreased by $1,600 per year. No. Let's talk about each of these. So, when it was purchased in year 0, the van was worth $1,600. Okay, so that looks promising. Did the van decrease in value of $1,600 every 1 year? No, it looks like it decreased constantly at $200 per year, or well, in about that area. So it's not that one. Did it increase in value? No. Did it have no value after 5 years? No, at 5 years it was worth $800. So it looks like when it was purchased, it was valued at that's $16,000. $16,000. Wait. So, hold on, typo. Wait. Nope. Wait. Yeah, typo. This should say $16,000 right here. Okay, I'm assuming that's what they meant. So, yep, so A is fine. A is the answer. Alright, let's go ahead and scroll down. Let's talk about 27 here. Rudy orders books from an online bookstore. Paperback books. So paperback books cost $6 each. Hardback books cost $12 each. He wants to order at least one hardback book. Okay, so he's going to be spending at least $12. If he plans to spend no more than $72, so $72, he's going to spend no more than $72. So $72 needs to be greater than or equal to the amount he spends. Which inequality represents the number of paperback books Rudy can order? Okay, so we're not going to need that. We need it in terms of books. So $72, well, we know that he's going to order at least one hardback. So let's just subtract the cost of that initial hardback to figure out how much money he has to work with to buy paperback books. So that's $60. So Rudy, after buying his one hardback book from his initial amount of $72, he'll have $60 left. And each paperback is $6 each, so he can buy a total of 10 paperback books. So he could buy, yep, right here, he could buy 0 paperback books, or he could buy all the way up to 10 paperback books. Yep, A is the best answer. Okay, complete the table of values. This asks you, can you read a graph? So when x equals -5, 1, 2, 3, 4, 5, 6, 7, 8. Y equals 8 at -3, 1, 2, 3, it equals 3. At -1, it equals -2. And at 1, it equals -7. Okay, let's go down to 29. Ken has $284 in his bank account. He needs to deposit enough money to make his car payment of $179 and still have $150 left in his bank account. Okay, so here's his bank account. He has $284 in it now. Here's the bank. He needs to make a car payment of $179. So let's subtract 179 from that right there. So 71501. So that'd leave him with $105 left in his bank account, but he needs at least $150 in his bank account. So he would need to add enough money to bring that balance up to $150. So that would be a cash inflow of $45. Let's see here. This is to make his car payment.